My name is Thomas Gazort, and this is my explanation video for Assignment 2, Linear Models for Internet Neural Networks. So, first thing is Exercise 1, Linear Classification. First thing we do is import all of the required libraries that we're going to be using throughout the entire thing. And then we load the diabetes dataset, print out the shape, and print out the diabetes dataset, as you can see here. And the second thing we do is convert numerical labels into categorical labels. What we're doing there is we're making everything that's above the mean a 1 and below the mean a -1. This just makes it easier to do classification problem. So we do that with this formula right here. Then as you can see, here's what it normally looks like, and here is the binary form. It's the same thing we did in the last assignment. So now what we want to do is do a training split on the values. So we want a 60-20-20 split. We can't do a three-way split with this function, so what we do is we do a 60-40 split with this, and then we take that 40 and then do a half split so that it's ultimately 60-20-20, and then we print out the shape of all of them, and as you can see, 60% and then 20%. Next thing we do, this was a given function up here. This is training the linear classifier, and then what we want to do is we want to get these utility functions to compute the predictions and compute the accuracy. They already have these functions built in, as we will use later, like here, CLF.score, but we're making them on our own. So what this is doing is giving the result is the matrix multiplication of x, the coefficient, and the intercept. This is basically a slope-intercept form equation. If it's above 0, it's a 1. If it's below 0, it's a -1, making it binary again, making it categorical. We reshape it to make it a 1D array and then return it. And the accuracy is just saying if it's the same as the prediction is the same as the actual, then it's 1. Sum it all up and then divide it by the total. This is just getting a what is it, a mean or whatever. It's just getting the accuracy and returns it. So as we can see here, we're computing these predictions here, and then we are computing the accuracy with these functions. Accuracy is around 75% for all of them, which is pretty good. And then the last thing we do is we just test these according to the built-in functions. They're the same because we did it correctly. So there we go. That is exercise 1. Now on to exercise 2, linear regression. Import the required libraries. This is generating a data set. This is something that was given to us. This just does exactly what it says. Generates a data set, and then we plot this data set here. Now what we're going to be doing is making a gradient descent function. Here's the pseudocode for that right here. So here for the first function, this is what each step, gradient 1 step, is doing. And under here, this is just saying do that for the amounts of times we've been specified to iterate. So what this does is it sets the initial values, gets n as the length of y, and then for each value in y, it does these two formulas. And what these two formulas are the gradient descent formulas. I believe I have it right here, yeah. So this is what these are. Theta is the slope, alpha is the, what is it called again? The learning rate. And that's essentially what these functions are, just put into Python. We do that for the slope and the intercept, and then we set the new slope to this function right here. And then we keep doing that for each value in there, generate the slope, and then do that as many times as we iterate. And then essentially the last value should be the closest to the actual graph, which we can see after we plot it. This is just us plotting what we got, and as we can see, the line fits it pretty well. That's because it went through 1,000 iterations to get closer and closer and closer until it eventually got very, very close, as we can see here. Alright, I believe that is everything that I need to explain. So yeah, this is assignment 2. Thank you.